Next trinomial factor. Don't be fooled by when they change the variables on us. And again, be careful when they change this, because especially when we get into our rational expressions, that can be one of the more common mistakes, and it's just generally a hasty mistake. Make sure whatever variable they give you, you use. Obviously, y times y gives you y squared. Just completely forget x's. Let's come over here and make our table. Factors of 12. 1 times 12. 2 goes into it, times 6. 3 goes into it, times 4. And once again, no, the table's never going to be that large. Even large numbers don't necessarily mean bigger tables. It's just a matter of how many factors go into it. First thing we look at, sign of the constant. What multiplies to be a negative? Got to have a positive and a negative. And remember again, it wouldn't matter what order you put them in, but what will matter, the way I get that plus is by putting the larger of the two factors with that plus, so just whichever one ends up being larger. Now again, when the constant ended up being positive, I added them. When the constant was negative, I subtract them. As a result of same sign, you combine, different sign, you subtract and take the sign of the larger. That's going to happen here. I'm going to subtract, I'm going to take the sign of the larger. 12 minus 1 is 11. 6 minus 2 is 4. 4 minus 3 is 1. Oh, that 11 is what matches. And again, you don't need to complete the whole table once you see what matches. Bring them on over. 12 and 1. Remember, the 12 goes to the positive because it's the larger of the two factors. Now again, the big picture, I could FOIL this and see that the middle term combines. But the big picture on factoring is we're trying to look for what multiplies to be a constant. 12 times negative 1, negative 12. 12 plus negative 1, positive 11. And that again, the signs are what tell us everything. For our next example, if we had x squared plus 13x minus 12, I deliberately picked the same constant and even the same sign so that we can have the same table and would not be as confused when we look at this. When we would start our binomials, go with whatever the variable is. X and x give us that x squared. Again, the habit of a lot of times this term we're going to see that x squared. Plan on just factoring as a product of binomials. That negative 12 means a positive and a negative. That positive means here's the larger of my two numbers. But here's where we run into a problem. When we make the table, and we can just create that same table for down here. I just don't want to create that whole thing again. The problem is there's no 13 on the list. And the last thing we can do is just try combining those, right? We can't just say, oh, well, if I make it a plus 12 and a plus 1, that would give me a 13. But the problem is that would give you a positive 12. We need those to be different signs, but if we make them different signs, we aren't getting the 13. What we would say here is, it doesn't factor. And that's okay. In fact, there are a lot of things we're used to things that don't factor. How about a number like 37? What's 37 factor as? 1 times itself. These are what we call prime numbers. These are what we call prime polynomials. And again, that doesn't mean anything good or bad. It is what it is. It just means it doesn't factor for us. And in fact, that will actually a lot of times mean something good for us because it just means less work that we need to go through. It doesn't mean no solution. It doesn't mean undefined. It doesn't mean anything crazy. It just says it's prime. It just doesn't factor.